In this video, we're going to take a look at the cosine rule, which is a rule that relates the angles and sides of any given triangle to each other using cosine. So the first thing we're going to look at is our diagram over here to the right, which shows how we've labeled the sides and angles of a triangle. The vertices of the triangle, the corners of the triangle, are labeled with uppercase letters. So we have the A, B, and C labeled over here. And the angles at those points are given the same letter, and also named with uppercase letters. So the angle at A is angle A, the angle at B is angle B, and the angle at C is angle C. Then the sides of the triangle are all named with lowercase letters, and they are all named in relation to the angle that they are opposite. So the side that is opposite angle A is named with a lowercase a. The side that is opposite angle B is named with a lowercase b, and the side that is opposite angle C is named with a lowercase c. So our cosine rule, the formula for this is a squared equals b squared plus c squared minus 2bc cos a. And that is exactly how it will appear in your formula book. But this will also work if you choose a different angle, so long as you swap out the letters to match. So the way this works when we're putting our cosine rule together is the side that is on its own to the left corresponds with the angle that is at the very end, and the other two unused sides fill in the middle. So if we're talking about angle A and side A, then B and C are the two other bits that fill in with the b squared, c squared, and the 2bc. But if we're dealing with angle B and line B, then A and C go in, or if we're dealing with angle C and side C, then A and B go into the rest of the stuff. So that's our three versions of our formula just here on the left. Our cosine rule is used to calculate the length of a side in a triangle when we're given two sides and their included angle. Because sine rule won't work for this, because we would need another angle opposite either the side marked 4 or the side marked 6 in order to use the sine rule to get the length of A in this particular triangle. Or if you look at the diagram on the right, when we're given a triangle, when we're given the length of all three sides, we can use the cosine rule to get the measure of any given angle within that. So let's take a look at two examples of that being put to use so we can see how this works out. So this right here, we've been given two sides, they're included angle, and we're looking for the third missing side that is not included in the angle. So we're going to use our formula that's written there on the top. So we're just going to put this together to start with. We're going to have a squared, which is the side we don't know, is equal to, and then it's going to be 8 squared plus 10 squared minus 2 times 8 times 10 times the cos of 60. And then we just have to solve this out, just filling in bits as we go. So a squared is going to be equal to 64 plus 100 minus 160 times the cos of 60, which is 1/2, like that. So we're going to have a squared is equal to 164 minus 80. So a squared is equal to 84, which means that a is going to be equal to the root of 84. So a is going to be approximately equal to 9.165 in this case. So that's how we would use the cosine rule when we're given two sides and then included angle to find the measure of the third side in any given triangle. Let's take a look at what happens when we've got all three sides and we need to find the length of an angle. So in this case, we've got an angle that we're looking for the measure of. We're given all three sides in the triangle. Our side A that we're referring to is going to be the side that is opposite our angle A. It's going to be this one over here. It's going to be the 6. So we're putting our equation together for this one. It's going to be 6 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 times the cos of A. Now it's going to work out what we count from this. So we're going to have 36 is equal to 25 plus 49 minus 70 cos A. And now we're going to do a little bit of rearranging in order to solve this. It's going to bring our 70 cos A over and our 36 to the other side. So we're going to have 70 cos A is equal to 25 plus 49 minus 36, which means that 70 cos A is equal to 38 So cos A is equal to 38 over 70, which means A is equal to cos inverse 38 over 70. So A is going to be approximately equal to 57.123 degrees. And that is that.